How does the pressure change with the depth? What is the equation, and what does each quantity represent? So, we talked about pressure and depth and how when you go deeper into a pool, okay, you feel more pressure. Okay, so what does that mean, and what equation are we going to use? Well, the equation we're going to use is this. The pressure is equal to the pressure at the top plus the density of the fluid times the gravitational field constant times the depth. Okay? And we're going to derive this equation in class. Okay? However, you do need to know the equation and need to know what each of the terms means. So pressure is the total pressure. P naught is the pressure at the top. Okay? And rho is density. And G is our gravitational field constant. And then H is the depth. Okay? Because if we imagine we've got this fish swimming in the water down here. So we got a fish swimming in the water at a depth below, okay? We're going to get the pressure that's exerted by the water on the fish here, but then there's the pressure from the atmosphere at the top, and that's what we have to add into our equation to get the total pressure. All right, so let's go ahead and try a problem. Two fish swim in a freshwater lake, one at a depth of 10 meters and the other at a depth of 80 meters. Assuming that the atmospheric pressure at the lake surface is 101,300 pascals, what is the difference in pressure on the two fish? Okay, so we've got two fish. Here's my lake. First fish swimming 10 meters below the surface. Second fish, a lot deeper, all the way down here at 80 meters below the surface. Okay, so we want to find the difference between the pressure on each of these fish. So let's find the pressure on the fish at 10 meters first. That is going to be the pressure at the top plus rho GH, density, gravitational field, depth. So the pressure on the fish that's 10 meters below the surface is the pressure at the top, which we know from the problem is 101,300 pascals. So we can go ahead and substitute that in. The density, okay, it says it's a freshwater lake. This is one of the values that we need to memorize. The density of water is 1,000 kilograms per cubic meter, so we can go ahead and substitute that in. G is the gravitational field constant. It's still 9.81 newtons per kilogram. And H is our depth, and the depth of the fish at 10 meters is 10 meters. If we type all this into our calculator, we'll get 199,400 pascals. So that is the pressure on the fish at a depth of 10 feet. Next, we're going to find the pressure on the fish that's at a depth of 80 feet. So 101,300 pascals. Still the pressure at the top of the surface, right here, is still 101,300 pascals. Plus the density, it's still in water, so it's still 1,000, times 9.81 because we're still on Earth. But now the depth changed, okay? The depth for the 80-meter fish is 80 meters. So now the pressure on the fish that's at 80 meters is going to be 886,100 pascals. Okay, so this is significantly larger. It asks, what is the difference in pressure? Okay, well, the difference in pressure means subtract the two. So 886,100 minus 199,400 is 686,700 pascals, and that is our difference in pressure.